in this section, we're going to look at ways we can measure the position of data relative to other values in a data set. The first kind of measure we're going to look at is percentiles. Percentiles split a data set into 100 evenly divided pieces. Okay, so percentiles divide a data set into 100 evenly divided pieces. So what does that mean in practice? Let's look at an example. Okay. Suppose we had an exam in our statistics class. Okay. And you scored in the 90th percentile on the exam. Suppose you scored in the 90th percentile on the exam. What does that mean? So first off, let's say what it doesn't mean. It doesn't mean that you got 90% on the exam. In fact, it doesn't say anything directly about what your score is on the exam. Instead, it's telling you what your position is, what the score on your exam's position is relative to the other scores on this exam in the class. Okay, so let's kind of imagine we have all the scores on a number line. So we start over here, this is our lowest value, and we go over here, this is our highest value. So this is our minimum value, and this is our max value. Okay, so in terms of our exam, this minimum value would be the lowest scoring exam. The very lowest exam in the class, way down there. And the very highest exam in the class, way up here. Okay? What the 90th percentile does is it tells you what place you are relative to the other exam scores in the class. Okay? So maybe you'd be, say, right around here. This might be the 90th percentile. And what that means is that 90% of exam scores are smaller than your exam scores. 90% of exam scores are over here. They're smaller than whatever score you got on the exam. Okay? And this right here, if I can draw it right, this then would be 10%, right? Because you need 100%. If 90% are below, then 10% are above. So 10% of exam scores. Okay? So notice it's not saying anything about what score you got. Now maybe you got a very high score. Maybe you got a 95 out of 100 on the exam. Okay? 95 out of 100 might be the 90th percentile. Okay, it might be the 90th percentile if 90% of the other students scored less than you on the exam. Okay, or if we look at the other direction, if 10% of students scored higher than you. Okay, or maybe it was a really, really hard exam and everyone did very poorly. Maybe you got a 72 out of 100 on the exam. Okay. It could still be the 90th percentile if 90% of the people in the class scored worse than you on the exam and 10% of the people scored better. Okay, so that 90th percentile, that's telling you where you are relative to the other data values. Okay, now how do we actually calculate a percentile? If we're going to do it by hand, it takes a little bit of work. We would have to put all our data values in order and kind of count to figure out where the 90th percentile is. It takes a little bit of work. We don't want to put in that much work, so we're going to let the calculator or the computer do the hard work for us. Okay? So if we're doing this in R, we can calculate a percentile using the quantile function. Okay. Now, what's the quantile function? What is a quantile, first off? A percentile is a special kind of quantile. Remember, a percentile, the idea is that it splits your data into 100 equal pieces. Okay? Quantiles also split your data, but into an arbitrary number of pieces. If you split it into 10 pieces, that's a special kind of quantile. Okay? If you split it into 70 pieces, that would be a kind of quantile. Percentiles are a very common and special type of quantile. Okay? So quantile is just a more general name for what we're seeing with percentiles. And the first thing we are going to tell the quantile is the data we're looking at. So X is the list of data that we're interested in. Okay, it needs to be able to look at the data. And the next thing is we need to tell it what's the relative position that we're interested in. This argument is called probs. It's short for probabilities. Don't worry too much about why it's called probabilities. It'll make sense later on in the course. For now, just take it at face value. But X here, that's our list of data. And probs, that is our relative position in decimal form. So it's easiest to think about this in relation to percentiles. So if I have, say, 90th percentile, if that's what I want, like I did in the example above, then what I would put in for that probs argument is probs equals 0.90. So just like if it's 90%, we convert that to 0.90. It's the same idea here. If we're interested in the 90th percentile, 90% is a decimal 0.90. Okay? So let's take a look at an example and see this function in action. Okay? Listed are 29 ages for Academy Award winning Best Actors. Find the 73rd percentile. Explain in words what this value represents. So we have a list of data, 29 ages. We want to find the 73rd percentile. So we're going to do this using our calculator. So I'm going to pull the calculator over here. Okay. And first thing I want is the list of ages. So remember how we do a list in R. We start with a C because we want to combine the values into a list, and then we add some parentheses. Anything within the parentheses will be our list. Now I'm just going to copy and paste this list into my calculator. Okay? The values are separated with commas, and all the values are within the parentheses. Okay, so that's my list. Now I want to give my list a name. I could call it anything I want, but because this data are the ages of the Academy Award winning Best Actors, I'm going to call it ages, just so to help me remember what it represents. Okay? And go to the end of the line, press enter so I could go to the next line. And now that I have all my data, I'm going to use that quantile function. Okay, I'm going to tell it the list of data I'm interested in. That's the first thing I tell it. So I've called my list of data ages. Okay, and now I tell it what quantile I want, what percentile I want. That's the probs argument, remember. I want the 73rd percentile. And so because I want the 73rd percentile, I need to convert that to a decimal form. 73% is a decimal, 0.73. Okay, and so this will tell me the 73rd percentile for the data that I have named ages. Okay, so let's evaluate. Do the calculation. And I get My 73rd percentile is 63.32. Okay? So the 73rd percentile is 63.32, and in this case we're measuring age, right? So 63.32 years old. Okay? We still need to explain in words what the value represents. Okay, so what does this actually mean? Well, from what we talked about before, a number is the 73rd percentile if it is larger than 73% of the other data values. So 63.32 is larger than 73% of the ages of Academy Award-winning Best Actors. Okay, that's one way to interpret the data. If you want to flip it around, you could say 73% of the ages of Academy Award-winning Best Actors are smaller than this. They mean the same thing, it's just saying it in a different order. Okay? So 63.32 years old, 73% of Academy Award-winning Best Actors are going to be younger than that 63.32 years old. Okay? Or if we look at it on the other side, 73% plus 27% is 100%, right? So if 63.32 years old is larger than 70% of the ages, then 63.32 years old is also smaller than 27% of the ages. Okay? So together, if you look at both sides, you have to get 100%. Okay?